Okay, we're going to spend a week or two on sequences and series. A sequence is just a set of numbers in a particular order. So something like football results by date would be a sequence, but not necessarily one that follows a mathematical rule. So the sequences that we look at will follow mathematical rules as well. Just a little bit of terminology. I think you've met this before, but just to double check. So this sequence here, we're timesing by 2 to get to the next term. And if that sequence was to continue, so that's an infinite sequence, I can put some dots on just to make that infinite. That's an example of a divergent sequence. So the numbers are just getting bigger and bigger and bigger, essentially. Rule is times 2 times 2 times 2. If you multiply by a number to get to the next term, that's an example of a geometric sequence, but we'll come back to that next week. So next one, get to the next term, I'm taking away 20, minus 20, minus 20, etc. Again, this, I think we really need to make it infinite to talk a bit about it being divergent, but it can be divergent and getting a bigger negative number there. And if you add a number to get to the next term, whether it's a positive or a negative, that's an example of an arithmetic sequence. So, yeah, it's spelt like the word arithmetic, but we say it as arithmetic, which I've never entirely worked out now. It's more of a descriptive word, I guess. If anyone knows the answer to that, let me know. So this one here, 5, 3, 1, 3, 5, 3, 1, 3. So this one repeats, so it's periodic, and the period is 4. So it repeats every fourth term. Trig functions are periodic, so they repeat every 360 or 180 for tan degrees. This one also is oscillating, so it's going 5, 3, 1, 3, 5, 3, 1, 3. So it's oscillating about 3. And it's finite. I better keep one finite one on there. So a sequence can be infinite or finite. This one, so we're on times a half. Times a half. So it's a geometric sequence. And I think it's quite easy to see that it's going to be converging. So the numbers as you go through get closer and closer to 0. So it's converging to 0. And we can look at the sums of those as well, but we'll do that as we go through. So that's your terminology. I don't think there's anything else you need particularly for that. Just checking my notes. Right, 2 sorts of definitions. First is deductive definition, which is like what you did at school when you found the nth term of a sequence. So that takes you from position to term. So, e.g., the nth term of a sequence is, so the notation might be slightly different. So un equals 3n squared plus 5. So tend to use lowercase u with the subscript for the terms. In some questions you will see a used instead of u. I guess they look quite similar, but yeah, it depends on the exam board a little bit as well. So you let n equal 1 to get your first term. I'll only sort of do 1 or 2 of these so carefully. 1 squared, 1 times 3 is 3 plus 5 is 8. And then when n equals 2, you get your second term. So I'm substituting in here for n and here. And so on. And then you could find the 10th term by letting n equal 10. And get to be 105. So that should seem really straightforward. We don't tend to work on here's a sequence, write down the nth term. That doesn't tend to get used quite so much in A-level maths, but we'll work on that when we get to it if we need to. Something just to get clear, that is notation for the first term. You need to make sure you understand the notation. That's the second term, that's the 10th term. So the 10th term is 305. So yeah, please get used to that notation. Makes the next definition a lot easier, more than anything else. So the inductive definitions take you from term to term. And I know some people just find this notation a little bit weird to start with. So, e.g., you'll always be given the first term, and then un plus 1 equals un plus 5, and then you'll be told where to start. Generally it's at 1, because, yeah, it will be a 1. So, you do the same thing. So if I let n equal 1, I'm plugging into here. So I'm putting n equals 1 in the left-hand side of this equation to give me u1 plus 1, which is 2. So it's the second term equals n is 1, u1, the first term, plus 5. We've been given the first term, so 7 plus 5, which is 12. And then when n equals 2, so I'm putting a 2 in here, the third term is equal to the second term plus 5, and we realise, and the second term is 12. And then you should get to a point where you can just realise that the next term along is the one before it plus 5. So I'm basically just plussing 5 to get to the next term, and it's an infinite series because n is greater than or equal to 1. I'll just do one more of those, I think. Just squeeze it on there. I'll turn the board over. So sometimes you're given the first 2 terms. So the first term is 2, second term is 5, and then un plus 2 equals 2un minus un plus 1, and n is greater than or equal to 1. So plugging into the second line here, when n equals 1, 1 plus 2 is 3. So the third term is equal to 2, n is 1, lots of the first term, minus the second term. First term is 2, so it's 2 times 2 minus 5, which is minus 1. And then you let n equal 2, so 2 plus 2, the fourth term is equal to 2 times the second term minus the third term. So the second term is 5, so it's 2 times 5 minus the third term, which is minus 1. So it's using the previous 2 terms to get to the next one along. And then you should find as you go through these get used. So I'm just adding one on really to that value as I go. So it's 2 lots of the third term, which is minus 1, minus the fourth term, which is 11, so that gives me minus 13, etc. So that sequence begins 2, 5, minus 1, 11, minus 13, like so. So that definition takes you from term to term. It's also called a recurrence relationship. So I just want you to start by doing a little bit of work on this.